This is project 1, video number 3, the one in which we do the documentation and the finishing touches. So I get started on this, but for my money, when I go to do this part, I need the printout of the project assignment so that I can use the checklist. There's a grading checklist at the end of it, and I can go through that. But I'm going to put down what I do remember. Okay, the first thing you got to do is write a description of the function. So I'll call it get final V's, and I guess I should say I'll just tell you, but it would be say what get final V's does. So you get, it's more or less from your project assignment. Describe what the situation is and see what get final state what your function does for you. Keep in mind, when you write your function, it doesn't have to be get final V's. Make sure you choose your own name for the function name, and the final velocities, it doesn't have to be final velocities. You choose the function name, or the return variable name for your function. But in this space, write a description of what the function does. This is called a comment. So this whole business is a comment, or this is one comment line and another comment line. Comments begin with a %. So when the first character in a line is a %, the compiler, the interpreter for MATLAB recognizes that it's just a comment. It ignores it. The comments are there for the human readers. So you got to describe what the function does, and then we need a list of the input variables. Those would be the arguments here. You can call them arguments, or I'll call them input variables. And so you'll have %m1, and then state state. In this space, I'll put in this space, right, a statement as to what M2 is, and then %. Again, remember, this is all just for human readers. You could use a colon there instead of an equal sign. M2 equals, and % to tell everybody, to tell the interpreter that which runs, what makes it so that your function actually executes as the interpreter, and these are just for the human reader to be ignored by the interpreter. And then %v2 equals, and of course here you would be writing not this statement, but a statement about what M2 is. Actually, the first one should have been M1. Then V1 and V2, and then output the variables final velocities, and you might say 2-element array first and then in this space write a statement. I'm going to use another percent. So, first element contains the final velocity of cart 1, you would say something like that, etc. So, make sure that you write it out in your own words there. So, yours shouldn't be, even if you're working with another student or you get help from Mr. Shard, so yours should be your own words. You should have your own words here, 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 etc. But you do need this format for the list of variables. And then you have to say who it's by. You have to have your name in the code. And then near the end of it, say right before the end statement, I'll put it right here. Percent, I'll hit return, so I got the percent right there. You need the word attribution. And then in this space, state what resources you used to help you write this code. Well, that was kind of cool. The editor created a new percent sign for me when I ran out of space there. So you got to say, for instance, I used Professor Schnick's project 1 video number 2 to write up the code, and project 1 video number 3 to help me with the documentation, and maybe use video 1 to check over to make sure I had the right idea, and probably to create an outline of the code. So be specific. I'm hoping that in the future you're saying, I looked up something, and you give me the web page where you looked it up, where you knew you needed to take the square root of something, and you figured there had to be a square root function, so you looked it up. Maybe you saw it in the Memrise course, so you could say, I also got information about this from the Memrise course. So be specific about what you got where. Give the web page, for instance, if you look something on the web. If you used the help function within MATLAB, I will admit that it's actually okay in the case of a help function within MATLAB to not include that. I'll call it outside. So I'm talking outside MATLAB, but it would be good if you used the help function from within MATLAB that you told me so. So that would be cool, but I will admit that you can still get credit for the documentation part if you don't include that. But you have to have the word attribution here and a colon if you use no outside resources whatsoever, because you just remembered how to do everything, you didn't have to look anything up, then write use no outside resources. So I wouldn't expect that to be the case in the first project, but perhaps on later projects you'll actually be in that position. But the point is, even though you didn't use any outside resources, you still have to have the attribution line in your code as part of the documentation. So I'm going to save it, and then I'm going to go through the checklist, and I got the printout on the handout right here. It says the pencil and paper part must have these parts: complete algebraic solution with before and after diagrams, depict both cards moving forward in all cases. I did that. Final expression should also include a similar symbols representing the given quantity or quantities. Actually, what I had in mind there, I think that's a typo, although it's good too. Represent. So to go by the letter of that, I got that covered in these expressions up here for v2 prime and v1 prime. What I meant to say, but you guys know you have to have this every time, is the symbols that you're using have to be defined up here. So I needed this arrow touching the object, and it's got to be labeled whatever I'm going to call the final velocity for card number 1. I chose to call it v1 prime. You don't have to have it v1 prime, but you got to have some label there. Same thing here, a symbol representing the quantity. These you didn't have any choice because they're given symbols. Nope, that's not true. You get to make up those as well, but these are pretty common. That's kind of what I would expect from you. But I guess you could have the initial, and I don't know. I can't think of another name besides v sub 1 and v sub 2 for those guys. Okay, and then for each function, well, we're only writing one function for this one, one .m file. An outline of the steps the program will execute, and that's supposed to be in my pencil and paper. And here's my code outline right there. Alright. This was extra, but comes in really handy if you want to be able to check and make sure your function is executing properly and doing what it's supposed to do. As for the program part, 1 point for a reasonable attempt at writing the program. Your program must consist of one or more .m files, as opposed to just statements that people have sometimes in the command window. You can't just have a bunch of statements in the command window. You actually have to create a function and save it as a .m file. Then 1 point for a program that works properly. To get this point, your program must correctly do what it's supposed to do. We verified that mine did that, but I should check again right before submission, because sometimes typing in the comments you accidentally change something. I don't think I did, but we'll make sure that it still works. To get this point, must correctly do what it's supposed to do. And if this, the semicolon, and I didn't check that, make sure nothing gets printed to the window. So let's go ahead and run it. I think I'll run it with those real simple values that I had worked out by pencil and paper. So there it is. If I run it without the semicolon, so I type it all in without the semicolon, I do get something printed to the screen, just answer equal, and then what the answer is. So I want to check if I put a semicolon there, make sure absolutely nothing gets printed to the screen. Okay, so if I run it with the semicolon, it's not very helpful as a check because I can't see what answer it's getting. But it is a good check for determining whether or not anything gets printed to the screen, and nothing got printed to the screen. We just have the next prompt, so saying it's waiting for the next command. So that's not, I guess, if you want to call that something printed to the screen, that's okay, but nothing other than that prompt. But I'm going to consider that nothing printed to the screen because it's not really my function that caused that to be printed. It's the fact that whenever you hit the enter key, it gets printed. Alright. So the function doesn't cause anything to be printed. Okay. 1 point for documentation. To get this point, you must have your name in it. So I got my name in every .m file, but we only have one. Your code must be documented for each function. This comment starting the first line after the function statement. Okay, this is the function statement. This line right here, that's the function statement. This is the first line afterwards, and that's where I started my comment. Admittedly, I didn't actually write a description of what the function does, but I at least told you that you have to. So if I were you, I would have my description of the function right there. Comments starting, okay, another set of comments providing a list of the arguments of the function, the input variables, with beside each argument a statement of what that variable is. Okay, so yours has input variables, or it's got arguments, and so there they are. I called them the input variables, and there are the names, and then you have to write what it is there. So obviously this is the mass of cart number 1, the mass cart 2, initial velocity of cart 1, etc. For the case of a function that returns one or more variables, and R certainly does that, it returns the final velocities. Comments must be provided that provide a list of the returned variables and state what each returned variable is. I've only got one, and here's what it is. It's a 2-element array, and this is what it's got in it, namely the 2 final velocities, but you have to write that out. For the case of a function that includes segments that are not self-explanatory, comments. I think this is such a simple program that everything is self-explanatory, given a good description of what's going on with the whole function. Saying up here you got to say something like, for the case of 2 carts traveling in the same direction on a straight track, cart 2 being behind cart 1, etc. So if you give that, then our code is self-explanatory. We don't have any confusing segments that we have to explain. And then you must provide attribution. So I talked about that. Admittedly, I didn't provide attribution, but I told you that you had to. You must include a comment giving attribution. So you get no credit for the documentation part if that's left out. So that's the end of the checklist. I've got it all. I've saved it. I made sure that it was still running and working without the semicolon. I get what I consider to be the correct answers. With the semicolon, nothing gets printed to the screen. So that's exactly what is supposed to be happening. So now it's time to submit, and I'm not going to be able to take you through the entire submit process because maybe I can. Let me see if I can. I think the window for submission is already open. I was thinking it wasn't for a second there. Alright, so I'm going to fire up a browser. I guess I got one already open. I'll go, I want to get to citrix.ansem.edu again, but I'll go www.ansem, where you tend to go all the time when you're looking at the college website. You can just type in citrix.ansem.edu, but you might not remember that 2 weeks from now or whenever the next project is due. So this might be easy to remember. Current students, IT, click on Citrix, log in. Go to assignments, project 1, no attachments, so we got to attach something. Go browse. I'm going H. There's the .m file. Upload it. I got the attachment there. I can go submit, and it's in.